Okay, we are live. A big hello to everyone who is back to our live. If this is the first time here, welcome. If you are here from Chegg, welcome. My name is Black and Red Pen. And if you're from my channel, welcome back. Welcome to the live office hour hosted by Chegg. And today we'll be talking about Trig and Precalculus. And we're going to be doing this until May, right? So every Monday from 6:45 p.m. Pacific time, and office hour will go for an hour. So from 6:45 p.m. Pacific time to 7:45 p.m. The goal for today is to help you get better at trig and precalculus. And if you have any questions, feel free to let me know. I also have prepared some common questions that I think that will be benefit to you. So we'll also be talking about that. So let's just go ahead and get started. We are going to first talk about this equation. In fact, we would like to know which of these right here is the one that has no solution. So go ahead, drop your answer in the comment and let me know. I can see the chat. So let me know which of these equations has no solution. Or maybe this is a trick question that everybody has a solution. All right. So go ahead, comment down below, let me know. And hello everybody for coming back to the live office hour hosted by Chegg. And yeah, let's talk about this. And then get your questions ready. And remember, next week, we will be back at the same time. Okay, so the first one, sin x is equal to 0. Second one, secant x is equal to 0. And then tangent x is equal to 0. Or maybe none of them is. I think everybody's getting it right. Good. But how come though? How come B does not have the answer? You're right. B is the one has no solution. So what's the argument that you will use to show that secant x does not have a solution? In fact, this right here is not even like no solution in the real world. This right here is just no solution at all. You don't even have like an imaginary solutions. None of that. Secant 0 is defined. Here, let me just make a quick note. I'm talking about which equation has no solution. I want to just bring this up. If we have secant 0, this is the same as 1 over cosine 0. And cosine 0 is equal to 1. So secant 0 is just equal to 1. Okay, so you can do secant of 0, but the truth is you cannot solve this equation. So what exactly do we mean though? Let's have a look. So I'm just going to use the graph argument. If you look at the secant graph, this is how you can do it real quick. So we have, let's say, 0 here, and then pi here, and then 2 pi here, and so on, so on, so on. And then perhaps also do a negative pi here. What we are going to do is we are going to do I'm just going to do the secant graph for you guys. The secant graph looks like this. You will have a bunch of vertical asymptote at the pi over 2's. This is pi over 2. And then 3 pi over 2. And a bunch of vertical asymptotes, and then so on, so on, so on. And then the secant graph goes like this. This right here is 1. And the first part is going to be like a U open up like this. And when you have secant pi is the same as 1 over cosine pi, which is 1 over negative 1. So this right here will be negative 1. And then you have this point, and then you have this. So you have a bunch of the U's. So I just wanted to continue with our discussion from I think last week or 2 weeks ago about the graph of cosecant. But if you graph secant, you will get like this. So let me just make it 3 markers in the hand. This right here, y is equal to secant x, the red one. But if you put on the blue one, which is going to be cosine, it will look like this. This is how cosine looks like. Cosine start right here, and then go down, go here, and then like this, and then like this. like this, and so on, so on, so on. The blue one is cosine x. Okay. But anyways, though, if you look at secant x is equal to 0, the red one never crosses the x-intercept, so no answer at all. Another way to look at it is secant x is equal to 0. This is 1 over cosine 0. Sorry, 1 over cosine x is equal to 0. What if you multiply both sides by cosine x? Will that work? No, if you multiply both sides by cosine x, this is 1, this is 0. Of course, this is false. Never have a solution, right? Never have a solution. Fun fact, not even in the complex world, you will just not have any solutions. So, welcome everybody. This was our first question. Today, I'm very happy to host another live office hour for you guys, hosted by Chegg as well. And our goal for today is to help you get better with Trig and Precal. So if you have any questions regarding your Trig class or Precalculus class, feel free to drop them into the chat and let me know what it is. Okay, I see. What about secant of what? Secant of what? Alright, so I see a comment. I think it's from TikTok. What about secant of what? You will have to let me know. Yeah, but I'm going to erase the board. In the meantime, you guys can put in your questions in the chat. And then we do have like until 7:45 p.m. Pacific time. So this right here will go for an hour. And next week, make sure you're turning on time. And if you are studying other subjects such as calculus and like even chemistry or biology, you can also check out. There's a QR code. Go ahead and scan the QR code so you can get to the social media of Chegg, and then make sure you follow them. Okay, let me see. Okay. So cosecant will do the same. You are correct. If you have cosecant, if you are trying to solve cosecant x is equal to 0, you get 1 over sine x is equal to 0. If you multiply this to both sides, game over. 1 is not equal to 0. So no solution. Not even in the complex world. But remember earlier I gave you guys the graph argument. It's tricky though. Sometimes if you want to get like really mathematical or technical, you have to be careful. Because if you look at the graph for x squared, which looks like this is y is equal to x squared. And if you look at this right here, y is equal to -1. Can x squared be equal to -1? Can x squared be equal to -1? The graph don't intercept, right? So this right here is no solution. Yes, I'm going to write that down. This right here has no solution, but in the real world, so I would say has no real solutions. Because the truth is, we do have the so-called complex numbers, or technically the imaginary number. Right here, if you want, you can take the square roots on both sides. Let me just write it down again. We can take the square roots to both sides, and then plus or minus x is equal to plus or minus square root of -1, which is I. So make a note right here. I is the number when you square, you get -1. And this right here is called the imaginary number, right? Technically, the imaginary unit. So sometimes when you use the graph argument, it might get really tricky. Yeah. So for this one, no real solutions, but you do have complex solutions. Okay, so good question so far. Now let me see. Okay, let me take a look right here what you guys have. Are imaginary numbers part of Precalc? Yes, Precalculus is pretty much half algebra and then half Trig. technically half of the harder version of algebra, and then half of the rest should be the harder version of trig, because you have done like algebra 1, algebra 2, and in pre-cal you do like more difficult algebra, and then trig you should have taken the trig class first, and in pre-cal you are going to just enhance your trig skills. Okay, let's see. Yep. Yes, in differential equation, trig never goes away. Yes, definitely. Yeah, enhance your trigonometry. It's really, really beneficial, even in higher level math and also physics. In physics, you have to use a lot of trig. Okay, let me see. Why I not J? For mathematicians, we use I. I think for J is for, I think because for the electric things, like the I for current, I could be wrong though. So they use J. Yeah, it's just a different notation. How can I tell if a function is odd or even by graph? Excellent question. So here is this is from Time Traveler, so let's take a look. Let me bring back our sine cosine graph. So if you take a look at the sine graph, it looks like this. This is just a quick sketch. But this does not do us any good, because when you are looking at a function, if it's even or odd, you have to look at the y-axis. So I'm going to extend it to here. So we are really going to focus on this part. So here is the sine graph, like this. And then if you go to the other way, it goes like that. Now have a look. This point is for the sine graph. When you have pi over 2, sine of pi over 2 gives you 1. And then if you come here, this is the other side. You have negative pi over 2. And in fact, this number here is negative 1. And this is actually true for all the values on the sine graph. And we say sine is an odd function. So here, note that sine of negative x, it's really the same as negative sine x. And in this case, we call this an odd function. When you have negative x in the function, if you can put that on the outside, that's an odd function. And the idea is that you can rotate it 180 degrees and you get a match just like that. So imagine, I'm going to get a piece of paper real quick. I'm going to use a piece of paper real quick. I will do this for you. So just give me a sec. I'm going to rotate this for you. So I have my x-axis and my y-axis, and I'm going to give you the sine graph. Okay, let me see. Okay, this is my sine graph. Okay, sine graph. So what's going to happen is that if you rotate 180 degrees, you get the sine graph back. Kind of, I know my picture is not that good, but the idea is if you rotate 180 degrees, you get back the original graph. So this is what makes a function odd. And you can also say that movement as this is symmetric. Symmetric about the origin, which is this point right here. And that's exactly what I was doing. If you rotate this 180 degrees, you get back to the original. For the even and odd, it's just left and right flip. But if you do the left and right flip, you see it's not the same. So this is odd. And for cosine, I'll just do it real quick right here for you. For cosine, the graph looks like this, like what we did earlier. And this is pretty much how cosine looks like. This is y is equal to cosine x. So cosine of negative x gives you, if you look at this point, you can go back here, positive x value, this point, negative x value still give you the same y value. So this is the same as cosine of x. And in this case, we say that's an even case. It's symmetric about the y-axis. I will write that down right here for you guys as well. This is symmetric about the y-axis. So just like that. Okay. So from the graph, I think it's the best that if you just kind of look at it, and then remember this right here is Trig here. Make sure you do the rotation to see it. Okay, so if you guys have any other questions, feel free to just post in the chat. In the meantime, I'm going to erase the board. By the way, how are you guys doing though? It's live, so if you enter your comments in the chat, I get to see it and I get to respond it. I will try to answer as many questions as possible. I see that you guys are discussing about even and odd in the chat. That's great. Okay. So right here, I'm going to actually put down another question on the board for you guys to try. I think this right here is pretty fun. So my second question for you guys, let me write it down right here. My second question for you guys is that it's not multiple choice question anymore. Try to figure this out. I'm going to ask you guys find the domain. Let's not do the range because range is trickier. Just find the domain for the function f of x. It's equal to 2 over, let's put a 2x, doesn't really matter, 1 plus tangent x. Find the domain of 2x over 1 plus tangent x. So I'll give you guys a few seconds to think about it. Help me out. What do we need to do though? So please, in the chat, let me know what do we have to do. How do we find the domain? How do we find the domain? Are we really live with you? Yes, this is live, brought to you by Chegg, and then we will be back next Monday as well, going from 6:45 Pacific time to 7:45. We are live, yes. Okay, find the domain. One of the hardest questions, right? Because you have to know what the domain is. I'm going to write down this right here for you guys. Domain is the set of all possible, right? All the possible x values that we can use for the function. Right? It's the set of all possible x values that we can use for the function. And the x values is the input of the function. Right? You see, f of x, x is the input. So sometimes I will also write it as input. Thank you for coming to a live stream. Yes, we're live. We're live. All right, so how are we going to do it? Thank you for the answers, Adam. Yeah, we pretty much have to solve this to be equal to -1. And I would like to give you guys a quick review. If you know the following, you pretty much know how to find the domains, all right? So this is how you are going to do it. 3 situations. I'm going to put this in blue. Situation 1. If you have a top function over the bottom function, right? You have to make sure that the bottom is not equal to 0. That's the first case. So this is case 1. Keep that in mind. Now, for the second case, if you have a square root, or technically any even root of anything inside, if x is inside, if you have an expression, you have to make sure that the inside is greater than or equal to 0. Just the inside. If it's an odd root, like a cube root, don't worry about it. It's okay to have a negative number instead of a cube root. But this right here, no. Lastly, the third one is if you have a logarithm of any base, if you have the expression inside, make sure this right here is greater than 0, because log of 0 is not defined. And you have to have log of a positive number in order to end up with a real result. So kind of similar to this, but this has equal because square root of 0 is okay. But log of 0 is not okay. So that's why greater than or equal to, just a greater than, and this is not equal to 0. So this right here might be a little bit trickier though. I think this right here might be a little bit trickier. I don't know if you guys can see what I see. That's why I really wanted to go over this one with you guys. Yes, you are right that if you look at the denominator, which is part 1, you just say not equal to 0. And this is how you set up the restriction. I agree. So this is the first case. 1 plus tangent x. That looks like a t and t. 1 plus tangent x. We cannot have 0 on the bottom. 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 Let's say this 3 times. Keep that in mind. All right, let's solve it. We just have tangent x, so we can move the 1 to the other side. So this is just tangent x equal, well, not equal to -1. Not equal to -1. Right? Not equal to -1. Now, where is tangent going to give us -1 though? Be careful with it. I'm going to give you guys a unit circle real quick. So on the unit circle, 45 degree gives you tangent being 1. Right here though, this is where tangent is going to be -1. And you can go across it. This is also going to be -1. So we're looking for this angle. This little much right here is pi over 4 because that's 45 degrees. So this angle here is 3 pi over 4. And you can just find out one answer because for tangent, the period is pi. So you can just start with one answer and then just continue, right? So you can just say we cannot have x being equal to 3 pi over 4. And then to get to the next point, just add pi, continue, and then subtract pi, continue to it. So we just put on plus n pi, where n is an integer, right? Just like that. Now, we are actually not done yet. We are actually not done yet. You have to pay close attention to how the function is written. So wait for a little bit. Right here, I'm setting up a condition, but this is not done yet. Okay, I see a lot of the comments. Yeah, if you wonder like why is it not done? Well, you're at the right place because we'll talk about it. Yes, you're right that we set 1 plus tangent x, which is the denominator, not equal to 0. That's great. But technically, there's another thing that we have to pay close attention to based on how the function is written. I'm going to erase this and I will tell you. Again, this right here, right? This right here, it's a key. And this is about domain. If you are finding a domain for other functions, maybe you can do another domain question later on. But for now, let's focus on that because we are not done yet. Tangent x cannot be infinity either, right? What does that mean though? Here's the deal. If you look at this right here, I will put this down in blue to make it more stand out. You will see what we are talking about. The 2x doesn't matter. Just let it, stay on top. Doesn't matter. But if you look at the tangent function, tangent is what? Tangent is sine x over cosine x. Have a look. Have a look. We secretly have another denominator, right? We have another denominator. So we will have to do that again. So this right here, we have to pay close attention to that. This part cannot be equal to 0. So that's the second condition. Cosine x cannot be equal to 0. Okay. And then let's just go ahead and use the unit circle. Cosine x is 0 right here because cosine is the x value on the unit circle. So here and here. So starting at pi over 2, from here to here is pi over 2. I am going to just do like this. But as you can see, to get to the next terminal side, we can just add pi. So from here, we can say that x cannot be starting at pi over 2, and then add pi, subtract pi, so on, so on, so on, the other way around. Just add n pi to it. Okay? So for this function, for the answer, I'm going to write this down. It's a set. This is a set. So I'm going to write it down like this. The set builder notation, x real number, such that x cannot be 3 pi, oh, sorry. Let me write it down better for you guys. 3 pi over 4 plus n pi from there, or x cannot be pi over 2 plus n pi. And then I will also have to indicate that where n is a integer, like so. Okay? So this right here is the answer. So be super, super careful. That's why I really wanted to go over this one with you guys. When I ask my students these questions, yeah, a lot of them will forget about this part. The top really doesn't matter. You can put like a happy face or whatever, it really doesn't matter. You have to worry about the denominator only. All right, now your turn. If you have any questions, leave it in the comment. Let me know so I can answer them for you. By the way, leave in the comment. Let me know what class are you taking right now. If you're taking any classes, just leave in the chat. Let me know. Back to the question earlier, because I just see the chat. I think maybe there's like some lag or so. If you wanted to fix that expression earlier, technically no, because you have to look for the domain based on how the function is written. Yeah, it's like this. If I say the function f of x is equal to x over x, what's the domain? Domain x cannot be 0. This function, okay, it looks like this. I know it's 1, but because it's how it's written, you have to really get rid of the 0 like that. So this is that function. I'll probably make it like this to make it stand out. Okay, so this is not 1. So because of that. Oh, some calculus and pre-calc. Nice. Number theory. Okay, nice. Elementary analysis. Nice. Enjoying math. Nice. Calculus 2. Nice. Calculus 3. Okay, they do have calculus office hours, so make sure you guys click on the scan the QR code and subscribe to Chegg so you guys can follow them. They have calculus live office hour this Thursday, I believe. So make sure you check them out as well. And then right now, I'll be waiting for your question. If you have any questions, please let me know. I will try to keep the questions within Trig and Precalc, right? Because that's what the goal is for this live stream, for this online office hour. You would be great with high school kids due to my personality, but eventually university. We get to see. Thank you. I taught high school students before actually. Sorry, for server's area of rotation, that will be on Thursday for the calculus office hour. Right here, we are talking about trig. So that's the goal for today. Again, we cannot do calculus. We're not going to do calculus, but there's one thing I can tell you though, if you guys would like to know real quick. Have you guys know about hyperbolic functions? Anybody who is familiar with hyperbolic functions? Hyperbolic functions. And depends on your class. Some pre-calculus class, they cover this because you do see this in either Calc 1 or Calc 2, depending on your school. And in pre-cal, again, depending on your school or your class, sometimes we introduce hyperbolic functions because it's very similar to trig functions. Who have seen this? Who have seen these functions like the sinh, cos, the one with h? If you have seen it, leave a comment. Let me know. It's me. Just putting me in the chat, so I know you guys have seen it. But if I see no, well, you can also type in not me. That is the exponential definition, Robert. That's correct. But why is this so similar to the trig function? So you see, sin, cos. Why don't they use different names? I'm going to give you guys a super quick introduction. Right? In the meantime, if you have any questions, you can also let me know. In order for me to connect this and then also the usual trig functions, this is the, I'm going to really write it as the, no, I'm just going to trig functions. So this is the usual one. And this is the hyperbolic one. Let's talk about this first. Right here. You can look at the trig functions on the unit circle. Here is 1. On the unit circle, when you put a point, let's say right here, and then if you go from here to here, let's say this right here is something, okay, something. The x value is cosine, and then the y value is sine. And then for the unit circle, the equation is x squared plus y squared is equal to 1. And you might be wondering, why didn't I put a theta or whatever? Don't worry. I want to go there. Go here. Hyperbolic. We're talking about hyperbola. We're talking about this one. I'm going to graph it for you. I'm talking about this. Okay? Hyperbolic. Hyperbola. It's open left and right. This is our choice of the hyperbola that we are going to use. Equation for this. X squared minus y squared is equal to 1. You see how we just changed from the plus to a minus and we get this graph instead? Pretty cool, huh? Now, we are not going to look at the left-hand side. We just want to focus on when x is greater than 0. Okay? Because otherwise we have to make the jump. No, we don't want that. So I'm not going to worry about that. So I'm just going to erase this part. Okay? Erase that part. Because we want x is greater than 0. Now, earlier we went over that if you put a point on the unit circle, you get the regular cos and sin. Cosine and sine. Right here, I'm also going to put a point on the hyperbola. Guess what? This is the hyperbolic version. The first x value is the cos, but I want the hyperbola, so we have to put the h. Something, comma, the y value is the hyperbolic version of the sine function. How cool is that? How cool is that? Now, something is cooler. Are you guys ready? Because you might be wondering, what happened to the input though? What's happening to the input? Now, usually when we do the input, we will go from here to here, and then we say that's the angle theta. But today we are not going to do that. Because if you go from here to here, it's not about the angle of rotation. It's not. So check this out. I'm going to consider this amount of area. I'm going to call that to be t. Right? This amount of area, I'm going to call that to be t. I'm going to make this in blue to make it stand out. This is the area, t. Guess what? Cos t, sine t. Well, almost. I'm going to show you guys. I'm going to show you guys. Hold on one sec. I'm going to call this area T, but let's really talk about what that is. Right here, I'm going to call this angle theta. This right here is 1. So what's the area compared to the angle though? So let me remind you guys the area of the sector. So it's like a pizza if you have the area. Okay. What's the area of the sector? Anybody help me out a little bit? What's the area of a sector? The radius is 1. Well, if you want to get, imagine this is the whole circle. The whole circle has pi r squared, but you look at the angle theta divided by 2 pi. Sorry, divided by 2 pi, yes. Because it's just a small portion of the whole circle. So it's theta out of the whole circle. And then you see the pi and pi cancel. So A equals here, you get 1/2. And then r squared theta. But r is equal to 1, right? So area is just equal to 1/2 times 1 squared theta. So area is just theta over 2. So now check this out. Earlier, if this part right here is the angle theta, which we usually put as theta, right? But I'm not going to do that. I'm going to erase this. Because if we have the angle theta, this portion we can label as T over 2. Not T, sorry. I think I wanted to go the other direction, but I think I'll do it this way. I'll call the whole area here T over 2. So it's theta over 2. What am I talking about? Theta over 2. This area is theta over 2. Theta over 2. Sorry. Theta over 2. The area is theta over 2. Here, the area. Now, here's the deal. This portion, okay, I'm going to call this T. And I'm also going to call this T. I'm going back to call this T. Sorry. Okay, this is cosine T, cosine T. What's the difference though? T is going to be just the area, which is theta over 2, is that area. And then right here, same thing. But anyways though, you pretty much have this area and that area, the idea. Let me see. Okay. All right. So if you enter this as T and this as T, then this area is, depends on how you want to say. I think I'm a little bit confused on the variable. I'm sorry about that. I think I will just say this area. Okay, I'm going to do like this. This area is, I'm going to do like this. This area right here is equal to 2 times is theta over 2. So I am going to call this T. If I call this T, then this is theta over 2. So it's half of the angle theta, like that. And that's the area. I think it's T over 2. Can somebody confirm with me real quick? Yeah. I taught in the afternoon, so I'm a little bit tired. I'm sorry about that. But anyways, though, if you look at this right here, this is how we get a hyperbolic function. And this is the x value. And you get the identity right away. Yeah, you get the identity right away, like that. Okay? So that's pretty much it. I'm going to double check on the area right here. But if I really want to check the area, I have to do calculus. So not today. I do have another video on talking about this like from many years ago. So you guys can go check that out. Okay? So that's the difference between, well, that's a connection between hyperbolic trig functions and also the regular trig functions, depending if you have done that in your pre-calculus or not. It's more like an optional topic. Maybe if you're in your pre-calculus honor class, they might show you these things right here. But yeah. Okay, let me see. Okay, let me know if you have any questions. I was holding my mic for a long time on the other day, so that's why my arm's tired. Yeah, the area is T over 2. The area is T over 2, so yeah. Back and repent, do you know of the arc tree functions navigation system? No, sorry. That I can look at into it later on. Yeah, I'm not familiar with that. Polar coordinates review. Okay, you got it. All right, history is fashion. You got it. Polar coordinate review. So the main thing is how we convert from rectangular to polar. And here's my usual story. Let's say you are right here, but you're hungry. You are trying to go find something to eat. So I'm just going to say, here's a restaurant. But imagine if you live in a city, then you have to draw in blocks. So what you are going to do is you put yourself in the middle, like a center like this, and then we can say 1, 2, 3, 4, something like this, and then 1, 2. So this restaurant to you, it's 4, 2, right? You have to draw in blocks. Imagine these are houses or like buildings. You have to go in blocks. So this right here, it's called the rectangular system. Rectangular. Or it's also called the Cartesian. Cartesian. I think I spelled it wrong, sorry. Cartesian. Most likely I spelled it wrong. So let me just keep it as rectangular. Okay, so keep in mind, 4, 2, the most important thing I want you guys to know is x, y. But for polar, it's the idea is like this. Now, it's like you're on the boat. This is the boat you are sailing or something. I can draw. And then you are still hungry, right? You're still hungry in this situation. You're trying to find something to eat. Let's say you are right. This is the restaurant right here on an island. So here's an island. But imagine if you're on the ocean, you don't have any blocks, right? Any restriction in your way. So what do? Of course, you just want to go straight to it, right? But here's the deal. Let's say I'm facing this direction, and then the restaurant is over there. Before you make your move, okay, you have to turn so much. You have to turn so much, see the restaurant in front of you, and then make your move. So you need 2 variables or 2 dimensions, right? Plane. So the first thing is that you're always going to be looking in this direction first by default. And then you are going to rotate so much. We call that angle theta. And then the distance from here to here, we call that r. So again, let's say the restaurant is over there. I'm facing this direction just like this. I have to turn so much. I see the restaurant. I'm going to go. Okay. Now, be careful though. This right here, we will have to write the coordinate with r going first. So this is r theta, right? R theta. So as opposed to x, y, we have r theta. And let me just make it more clear. And then this right here, in general, it's x, y. So that's the idea. Is that okay so far? So hopefully you like the story. Now, I just want to show you the conversion formula real quick. Regular, the rectangular, and this is polar. So regular is x, y, and then polar is r theta. Now, how do we go from rectangular to polar? Have a look. Right here, we know the x, which is the horizontal distance, and then we also know the y, which is the vertical distance. I need to find from here to here. R is the distance from here to here. Okay, so first thing, r squared equals, thanks to the Pythagorean theorem, r squared equals x squared plus y squared. Formula number one. Okay, formula number one. Now, second one, we need to know the angle, how far we have to turn, right? How much we have to turn. That's the angle theta. Have a look. Opposite, adjacent. Opposite, adjacent. Tangent. Theta equals opposite over adjacent. So these are the formulas that you need. When you are given, let's say it was 4,2, plugging, work that out. Plugging, work that out. Okay, how do we go from polar to rectangular? Now we are given our theta. Let's find x first. Let's find theta. Let's find x first. Have a look. We are about to get a right triangle. We know the hypotenuse, we know the angle. So what can we do? Cosine. For this right here, I would like to keep it as tangent theta equals y over x, because if you use inverse tangent, you actually have some restrictions, because inverse tangent only gives you from negative pi over 2 to positive pi over 2. It does not give you the angles on the second, also the third quadrant. So not that great, but this right here is more general. Now we have adjacent, hypotenuse. What can we do? Yes, cosine. Cosine theta. Actually, what color? Oh yeah, let me do it like this. Cosine theta. Cosine theta is equal to adjacent over hypotenuse. Now multiply r to both sides. We see x is equal to r times cosine theta. Now to get a y, we use sine. Sine theta equals opposite over hypotenuse, y over r. Multiply r to both sides, y equals r sine theta. So these are the four main formulas, right? So here we have these two, and then these two. Maybe next week I can show you how to convert a rectangular equation to a polar equation. Unless you have any specific questions that you would like to know, then I will be happy to answer them for you. Okay, and then, yeah. Do you guys like my picture? All right, for the people who just came, thank you guys so much for tuning in. Welcome to the online office hour brought to you by Chegg. Today we're doing Trig and Precalc. And make sure you guys do me a favor, go ahead and scan the QR code, follow Chegg, follow their YouTube, Instagram, Twitch, and TikTok, so that you guys can get more content like this. There are other great instructors on their social media, especially on YouTube, where you can see the live streams. And they have different schedules. You can go check that out, but click on the scan the QR code over there. Finally, I was able to catch you live. Thank you so much for coming. Thank you so much. Formula for angle of clock. What do you mean by angle of clock? That I'm not so sure. I'm sorry. Thank you for the super chat, Mashi. And then everyone wants to know how you draw circles so well. I don't think I draw circles so well. Like this? Can you do the double angle examples? Do you have a specific question though? I think that would be easier for me to help you. Double angle examples. Do you want me to solve an equation, or do you guys want me to prove the identity? And remember, if you guys scan the QR code, you guys can get all the schedules. And then if you would like, definitely take advantage of other instructors as well. They have plenty of helps with Trig, Precalc, and of course also calculus and chemistry also. Can you demonstrate law of sine? Do you have a specific question, or you want me to do the proof, or you want me to do some computation? I can do a proof if you would like. How's that? Proof? Okay. I'm just going to write that down first. Law of sine. The law of sine doesn't take that long, so I should be able to do it within the rest of time because we don't have 10 minutes left. Let's see. Hard identity problem. I can give you one and maybe you come back and then we can talk about it next time. So just real quick, prove the law of sine. Okay, prove the law of sine. So you can start with any triangle. Any triangle, doesn't matter. Any triangle. Okay? This is not equilateral triangle. I will try to make it look more like a non-equilateral triangle. Okay? Definitely not equilateral triangle now. This is how you label. A for angles. This is this angle. And if you go away, use lowercase for the side. So capital A, lowercase a. And then let's go right here. B, B, C, C. So that's how you label it. Now, the idea is how we are going to find the area, and we use the area argument to make sure that we can get the law of sine. This is how. Suppose we want to get the area, right? Suppose we want to get the area. Area is always what? 1/2 times base times height. For the base, you can take any side for the base. Let's just stick with this. Because it has B labeled already, that's very nice. But now what's the height though? Well, the height is you go to the other vertex, you are going to drop a perpendicular, like so, and then you call that H. Now, here's the deal. This is perpendicular. So now we can work with right triangles. Look at this triangle here. This is the angle A. If you take sine of that, don't we get opposite over hypotenuse, which is H over little c. Multiply c to both sides, we get H, which is the height, is equal to c times sine A. So we can put that down right here for the height, the H, which is just that. The height is H, and then 1/2 base, and then c sine A. Here's the deal. In general, when you have an area, right? Let's say you have as long as you know this angle, and then let's say this is side 1, side 2, you can always find out the area of the triangle. The area is just going to be 1/2 this side times that side, so the adjacent sides together, S1 times S2, and then you times sine of the angle in between. That's the area. Okay. Now, I proved that right here, and here we are going to do the following. If we take this angle for our consideration, and look at that angle, the area, just like what we went over earlier, I'm going to spell that out. This is equal to 1/2 the adjacent sides. Ignore the height. The adjacent sides multiply. So B times C. And then times the sine of the angle A. That's the area. But I don't have to do it like this. I can also look at this right here for my angle. In that case, 1/2 adjacent sides we multiply, so A and B, and then we have sine C. And that's exactly what we went over here. Okay, we can also do the same thing for B, right? But as you can see, pretty soon, right here, the 1/2 cancel if you look at this equation. So we have BC sine A equals AB sine C. B and B cancel. Of course, B is not equal to 0, so perhaps I will denote that. Otherwise, it's d by 0, that's not good. C times sine A equals A times sine C. Depends how you like it. You can divide both sides by C, and then you can also divide both sides by A. So C and C cancel, A and A cancel, so I'll divide A right here. So here, ladies and gentlemen, sine A over little a equals sine C over little c. Yeah, of course, we could also have done that with the angle B, and you will end up with sine B over little b. And that's the law of sine. Okay, so we just have 5 minutes left. So yeah, let me just kind of check out what you guys have said so far. Okay, we're not doing the plus transformation here. Law of sine is really useful for area, yes. Well, actually, maybe the other way around. Area is useful to prove the law of sine, and then the area argument is awesome. You can prove a lot of stuff with the area argument. I will maybe phrase it like that. Okay, so do you guys want to see anything in particular next week? Because we are going to come back next week, Mondays, right? Mondays from 6:45 p.m. Pacific time to 7:45 p.m. Pacific time. If this hour doesn't work for you, don't worry. You can watch the replay on my channel and also on Chegg's channel. All right. But if you leave your answer, if you leave your questions right now, I will remember it and I'll try to do that for you next week. We do have just 1 hour, so I cannot do like big questions. But I will answer as many questions as possible when possible. Yeah, like the Euler circle, I think that might be a little bit too hard to explain that in a short amount of time. Like we have like 3 minutes. Yeah. So thanks for the office hours, Professor Black-Rippin, and thanks Chegg for supporting this. Thank you so much. Yes, thanks to Chegg for giving me this opportunity as well. Yeah, it's fun. So far, this is the third one. I love it. And hopefully you guys have fun too. Didn't I post a video where we have to be careful with law of sine? Yes, I did. Law of sine versus law of cosine is one of the, you have to be careful with that. That's a great question. I'm going to use that to start for next week. I'm going to do that on live next week with you guys. Okay. So we are almost out of time. So before we wrap out, I just want to give a huge thank you for you guys joining today. And thank you so much. Thank you for your engagement and also your questions. And it's a pleasure. And I love seeing you guys' comment. Yeah, it made me feel really touched. Thank you so much for all the support that you guys have given me throughout these years. And thanks to Chegg for hosting this live stream so we can do this. Before we go though, don't forget to check out Chegg.com if you haven't done so already. Please scan the QR code. Right? Please scan the QR code if you haven't done so already. They are here. We are here to support you guys all semester. And you can check out Chegg for more information on that QR code. And make sure you follow Chegg on TikTok, YouTube, Instagram, and Twitch. They even have a Twitch account. So if that is your thing, then you go ahead and check them out. All right. So next week, we are going to be back Monday from 6:45 p.m. to 7:45 p.m. Pacific time. And then I will do the tricky law of sine question for you guys. That will be my opening question. Right? And then again, Trig will pre-calc. Maybe we can do some algebra things next week for you guys. Okay? Thank you guys so much. Once again, thanks Chegg for hosting this office hour. And I'll see